Okay, so here is the banana that our starter question was all about, and we want to find its volume. Well, we could measure its length, we could measure its height, but that's not actually going to tell us anything. Our formula that we worked out, or that I gave you in this week throughout the lessons, has been all about cuboids. So it's not going to help us find the volume of our banana. It's a very odd, irregular shape. But some maths by an engineer or a mathematician called Archimedes really is going to help us. Now, the story goes that Archimedes jumped into his bath, and he noticed when he went into his bath, instead of the water being able to take up that space, he took it up. And so the level of the water in his bath went up when he got in. And he realized, and he called this displacement, he realized that getting into his bath could tell him his volume, because how much water had been pushed out the way, well, he could calculate that and find out what his volume was. So we're actually going to do that little experiment. We're going to follow Archimedes' steps and see whether we can calculate the volume of our banana. So I've got myself a little bucket of water here. And you can see, hopefully, that I have marked on already the level of the water in that bucket. We're going to put it in. And hopefully you can now see the water level has gone up. It's not the same anymore. It's pushed water out the way until we're up at that new level. So let's try and measure that and find out how much the water level's been pushed up by. So it's been pushed up by what looks like about 0.6 centimeters. So we're going to calculate the volume, which is 0.6 centimeters high, and then the area of this bucket, because that'll tell us how much water we have got. So let's do that. So let's jump to a bit more of a vertical view. Okay, so what Archimedes was realizing was when he sat in the bath, the water that gets displaced or moved out of the way by that object, that person getting in, is the same shape as the box, and however deep the level that it's risen by. So 0.6 centimeters is how much it rose by. We can measure our box. So our box here is about 11 centimeters wide, and our box is, I've lost my big ruler. I'll do it with my little one. Oh no, there it is. So my box is about 18.5 centimeters long. So there's my length of my box, and now we can calculate its volume. Well, let's zoom in and see what our little sketch shows us. So let's find its volume. Volume equals length times width times height. The length is 18.5, the width is 11, and the height is 0.6. Now we can get our calculator out and we can find out what that value is. So we can do 18.5 times by 11 times by 0.6. And it gives us 122.1 centimeters cubed. And that's our volume. So actually this little experiment is a really helpful way to work out the volume of irregular objects. But all you need to find that is being able to find the volume of a cuboid. Hopefully that's interesting and also just made you think a little bit.